the first thing you need to do is you need to go to aplusstudents.com. You need to go to the website. Once you're on the website, you need to select math as your subject. This is a grade 10 maths lesson, and the name of the topic is algebra, and we are going to review the topic. Okay, I'll give you the chapter number and the lesson number. The chapter number is 1. Chapter number 1, lesson number 9, and the name of the lesson is solve linear inequalities. So let's go to the topic. Chapter number 1, lesson number 9. So the linear inequality means that either we have a greater than sign or less than sign, right? So let's solve this. So the question number 1 we have is this, and the question says solve for j such that 12j plus 154 is greater than minus 2, right? Can we add, if this is a positive 154, can we subtract 154 on either sides? When we subtract 154 on either sides, we are left with, this was a negative 12j. 12j is greater than, if both the signs are negative, we add them together, 156. Okay. What we need to consider in this question is that since the variable has a negative sign, right? So what we do is we divide both the sides by a negative 12. Whenever we are dividing the variable by a negative number, what we do is we invert this sign. Okay, how do we invert? From greater than, it becomes less than. Minus 12 is cancelled out with negative 12. That means j is left over here. A negative sign is cancelled with negative sign. And 156 is to be divided by 12, which can be written as j is less than 156 divided by 12 is 13. That means j would have any value which is less than 13. Okay. Okay. Let's draw it on number line as well. A number line is a representation of data such that the left side represents the negative infinity and the right side represents the positive infinity. We only have a less than sign over here. It does not have an equal. When only we have a less than sign, that means it's not included. Okay, so we draw a circle. Whenever the values are included, we will draw a dot. I'll do a similar example with a dot. Okay, so what we do on the number line is we need 13. We can write the numbers 12, 11, 14, and 15. Agreed? J is less than 13. So you make a circle at 13 and the lesser values on the left side, and we draw an arrow over here representing this. So this information of the inequality is now represented on a number line. This is called a number line. Okay, let's look at another example and let's see what we can do over here. Okay, for the next question it says if I would change the question, I would pick the same question, but without, okay, let's take an example. If we have the same question, but let's change the sign over here. Rather than having a negative, let's make 12j a positive. Okay, let's see what happens for the positive for question number 2. The same step for the first value. We take 154 to the other side. We subtract 154 on either sides. This is cancelled out. So we can write this as 12j was greater than minus 156. Agreed? We know that this has a positive coefficient. So when we divide with a positive coefficient on either sides, we do not change the sign. Okay, 12 is cancelled with 12, and we can write j is greater than minus 13. Agreed? Okay, rather than greater than sign, let's put a greater than equal. Okay, we did not flip the sign. This sign stays the same because the variable was positive. Now what happens is, if we have an equal sign, it means it's included. And we will draw a dot. Dot means a shaded circle. Let's draw a number line. If we have a number line, we know that the left side is a negative infinite and the positive right side is the positive infinite. It can extend to positive infinite. J is greater than equals to minus 13. Can we put a minus 13, minus 14, minus 15, and let's suppose minus 12, minus 11, and minus 10. The greater the number in negative, the smaller it is, right? That means j is greater than minus 13. We make a circle on 13, but it has an equal, we shade the circle. A number greater than minus 13 is negative 12. It could be negative 10, and so on, right? So we move to the right side because it's a j is greater than equals to minus 13. Agreed? Any questions up till now? Okay, let's move ahead to the next question. For the next inequality, what they are saying is, okay, just a moment, please. Question number, we just need to remember this. When it's just a less than or greater than sign, we make a circle. When they have an equal sign also, we make a dot, a shaded circle, okay? For the next question, it says, solve for d, find the values of d such that this is the given information we have, okay? For question number 3, what we can do is, either we take a negative 8, that can we add 8 on either sides? So can we say the inequality comes out to be 5, d minus 100 is less than equals to 10. If we divide both the sides by a 5, we can say d minus 100 was less than equals to 2, because this is 5 times 1 and 5 times 2. If we add 100 on either sides, because we need to remove the negative 100, right? So can we say that the value of d is less than 102? If we wish to draw it on a number line, we don't have to worry about how big a number is. All we need to see is This was negative infinite. This is positive infinity. In the middle, we write 102, whatever that value is given to us. Going towards 0, this is 101. This is 100. And over here, 103 and 104. More than enough. That means the value of D was less than equals to. That means it has an equal. We make a dot at 102. It could be 102, it could be 101, or it could be 100. Any value that is less than. Okay? So we are trying to draw this inequality on the number line as well. That means whenever we have an equal sign, we draw a dot. Whenever we don't have an equal sign, we draw a circle. Okay. For the next question, it says, solve for B such that the inequality given is, let's see. Okay. For question number 4, they're saying if this is the inequality that is given to us, this is our question number 4. And we need to find the value of B. We need to solve for B, the range of values of B, right? If this was plus 18, can we subtract 18 on either sides? So we can say B upon 12 is greater than positive 6. Since B is divided by 12, can we multiply each side by a 12 in order to remove this denominator? So we can say B is greater than 6 times 12 is 72. When we draw the number line, we can say we have the negative infinity. This is a positive infinity. We write the number 72 in the middle. This would be 71. This would be 70. Smaller numbers on the left side, larger numbers goes towards the positive infinity on the right side. B is greater. It says B is only greater than 72, right? That means we don't have an equal sign. That means at 72, we draw a circle. That means B is not included. 72 is not included. B cannot be 72, but it can be any number greater than 72. That means 73, 74, 75, all are greater numbers than 72. So we represented this inequality on a number line. Okay. Moving ahead, let's have a look at the next question. The next question says, solve for B, the variable B, such that the inequality given is, if this is the given inequality, we need to find the values for B. Okay. This is our question number 5. We have a plus and we have the left hand side of the inequality is greater than equals to the right hand side of the inequality. Can we subtract 185 on either sides? To move it to the other side, this is cancelled out. We are left with 6 is multiplied by B minus 95, which is greater than equals to, and 197 minus 185 would be 12. What we need to see is we have an equal sign, right? So can we divide both the sides by a 6? So we can say 6 times 1, 6 times 1, 6 times 1, and 6 times 2. So finally, we have the inequality that is B minus 95 is greater than or equals to 2. If we have a minus 95, if we take minus 95 to the other side, we can add 95 on either sides. Therefore, the final inequality becomes b is greater than equals to 97. Let's try drawing it on the number line. We had negative infinity, we have positive infinity, we have 97. Let's draw 97 in the middle. This is 98, 99. 2 or 3 numbers are more than enough on either sides. Okay. In this case, it says b is greater than or equals to 97. That means b can be equal also. So whenever it's equal, we draw a dot. And greater than means b could be 97 or any number greater than 97. That means it could be 98, 99, 100, and so on. So what we did was the inequality, we find the answer and we plot it on a number line. Moving ahead to the next question. Question number 6 says that solve for h such that the given inequality is, just a moment please. If this is our given inequality, let me copy this again. Okay. This is our question number 6 with a plus sign and just a greater. The left hand side is greater than the right hand side. So we have a plus 33h plus 85 is greater than 184. So we subtract 85 on either sides because we need to remove the 85. So can we say 33h was greater than 184 minus 85 would be 99. Since this is a positive, we do not have to change the sign. We do not have to flip the sign. Agreed? Okay, the next question I'll do with a change in sign. Okay, just a moment, please. This is our question number 6. This was 5. Just a moment. This is our question number 6. Okay. So what can we do over here is we divide both the sides by a 33. And we can say 33 times 1, 33 times 3. So what we can say is h is greater than 3. Okay. When we need to draw it on a number line, what we can say is it could be negative infinite. Horizontal 8 means infinity. Okay, this was 3. This would be 4, 5. This is 2 and this is 1. H is greater than 3 but not an equal sign. Okay, this means h is greater than 3. But if I would consider the same question with a negative sign, okay, let's see if we can do the same question by introducing a negative sign. Okay, let's suppose that in question number 7, this had a negative sign. Okay, let's see what can be done with this. Okay, sorry. Let's see what we can do over here. If the variable is with a negative sign, we can do the same working, right? We can put a negative 85 on either sides. We simplify. The only concern is the sign in the middle. So what we are left with is negative 33h is greater than 99. So whenever we divide by a negative number, if the variable has a negative coefficient, a negative number next to it, when we divide by a negative number, right? So what we do is we flip this sign. flip the sign or the inequality. Since this was greater than, it becomes less than because of this negative sign. Negative 33 is cancelled with negative 33. So we can say h, which was previously greater, now becomes less than minus 3. On a number line, what we can say is we draw the extreme ends, a negative infinity, a positive infinity. We have negative 3. Okay. Smaller number than negative 3 is negative 4, negative 5. This would be negative 2, negative 1, and 0 onwards. In this particular case, what they are saying is h is less than, no equal sign, right? We make a circle and h is less than minus 3. That should mean it could be minus 4, minus 5, and any number. I did this example just to show you that we would flip the sign if the variable is in negative. Okay? Comparing question number 6 and question number 7. In question number 7, it was positive, sign stays the same, right? But since here it was negative, the sign will be flipped. We flip the sign of the inequality. Agreed? Okay. For the next question, let's have a look at this. Solve for n such that the given inequality is, let me just copy. If this is a question given for us, question number 7. This is our question number 7. And they are saying 48 is greater than equals to, wherever is the open end, that is the greater value. Greater than equals to 6 bracket n minus 165. Can we divide by 6 on either sides? Right? 6 times 8 is 48. So we can write 8 was greater than equals to n minus 165. We can add 165 on either sides to cancel out the 165 on the left hand side. So can we say 168 plus 165 would be 173. So we can write 173 is greater than equals to n, right? Can I write the same inequality as n is less than equals to 173? Would these two answers be exactly the same or they have a difference? Are they same? See, what we are saying is 173 is greater than equals to n, or n is less than equals to 173. They would mean exactly the same. Let's draw a number line. We do not have to worry about the starting point. We just need to consider the number that we have in the one. We have 173. We mark 173 in the middle. It's positive 174, 175, 172, and 171. It says n was less than equal. Equal means we make a dot because it's included, and a lesser value would mean it could be 172 or 171 or 170, any number smaller than equals to 173 or smaller than 173. Okay. Any questions up till now? Do we have any questions up till now? Okay. So we have the rule that whenever the variable was negative, right? The next question, question number 8. If this is our given information, This is our question number 8, and they're saying this is -1, which is less than, okay? Any number divided by 1 would stay as 1, right? This is divided by 1 and this is divided by 1. So we can say this becomes minus p minus 32 is less than 12. Agreed? For which we can say we keep the minus p on this side and we add 32 on either sides. So can we say minus p was less than 12 plus 32 is 44. And we have the rule that whenever it's a negative sign and we change the sign, it means we multiply. Okay, I'll write down the statement. Basically, what we are doing is we multiply both sides by -1 and we flip the sign because the variable was negative, right? So minus p becomes positive p and this becomes minus 44. The sign is flipped and this becomes this. Agreed? Because p was negative, we change it to a positive. Let's draw it on a number line. We say the numbers given to us are, this is negative infinity, this is positive infinity, extreme ends. We said this was negative 44. It's in a negative number, negative 45, negative 46, because negative 43 is greater than negative 44, right? P, it says P is greater than negative. We do not have an equal sign, right? We simply make a circle. Greater. Which number is greater? Is negative 45 greater or negative 43 greater? The greater the number with a negative sign, the larger the number with the negative sign, the smaller the number is. The closer to 0, it becomes greater. So that means P is greater than minus 44. That means these are the greater values. It could be minus 43, minus 42, minus 1 also. So we can move on the right hand side. And we represented this information of the inequality on a number line. Okay. Let's have a look at another example. Okay. So the next question, it says, solve for the function, solve for f. The variable f is given to us. And we need to find for this question. Just a moment, please. Okay. This is given as question number 9. And it says 3 is greater than equals to f upon 23 minus 2. Okay. So how can we simplify the equation? Can we add 2 on either sides? Because 2 is a number, right? That means we can write this as 5. The sign will not change because the variable is not in negative. We can multiply each side by 23 to remove the denominator and the denominator, and this was positive, so no need to change the sign. 23 multiplied by 5 would be 110, 15, right? Plus 5. So we can say 115 is greater than the value of f, or we can also say f is less than equals to 115. Both of these representations of the answer are perfectly correct. Why? Because if 115 is greater than equals to f, that means f could be 115, right? Or any smaller number, right? So let's draw it on a number line. If we had the number line here, we had the negative infinite, we had the positive infinity, we had the numbers 115. When we go towards the right side, we increase the numbers. Agreed? When we go to the left side, we decrease the numbers. F is, it says, F is less than equals to 115. But we can see an equal sign. That means we make a dot. And it's less than. That means we go to the left-hand side. The possible values of F would be 115, 114, 113, so on till the any negative value, right? Because it's going towards negative infinite. Let's have a look at the next question. Any questions up till now? Do I need to explain something particular? If you have a question, please do let me know. For the next question, it says, we need to find the value of R such that 174, okay, this is already negative. This is our question number 10. We can see that this is negative, right? We can keep it in a bracket also because it has a negative sign next to it. What can we do? Can we subtract 174 on either sides? Can we take 174 to the other side? And we are left with minus 4R was greater than equals to 174 minus 110 would be 64, but with a negative sign, right? Once we can see that the variable has a negative sign over here. So what we do is we divide both the sides by a minus 4. But this sign will be flipped. Why? Because the variable had a negative sign. Minus 4 and minus 4 is cancelled out. We are left with R. Minus minus cancelled. 16. 4 times 16 is 64. That means the value of R for this number line is minus infinite plus infinity. This was 16. We can say 17, 18. This was 15, 14, and so on, right? The numbers can decrease on this side. So what we can say is the value of R is less than equals to 16. It could be 16 because it has an equal sign, or less than 16. These are the answers on the number line. But if I would take the same question and I would say that there was no negative sign. Okay. This is question number 11. There is no negative sign and there is no equal sign. There is simply 174 plus 4R is greater than 110. I'm just making small changes to the question number 10 to make it question number 11. We do the same working. We subtract 174 on either sides. Because it's a numerical value, we can say 4R was greater than minus 64. But now we can see that the variable is positive. So all we need to do is divide by 4, divided by 4 on either sides. So can we say R is greater than minus 16? When we draw it on a number line, which number is greater than minus 16? Minus 15 or minus 17? See, this would be 0 somewhere, right? If we say this was negative 16, the greater the number in negative, the smaller it is, right? With a positive sign, the number would increase, but with a negative sign, the numbers decrease. Okay. So what we can say over here is x is greater than, that means you make a circle, it's not included. Because in the previous question, it was included because we had an equal sign. So x is greater than minus 16. A number greater than minus 16 is minus 4, minus 15, a 0, any number. So that means we draw the line on the right side. It shows that any value on the right side of the number line will be greater than minus 16. Okay, let's have a look at another question. For the next question, it says, find the value of n such that, okay, just a moment, please. Question number 12. This is our question number 12. So let's find some values. What we can say is this is greater than and equal, right? I'll just rewrite this, greater than and equal. So if we had a plus 143, we can subtract 143 on either sides. 62 minus 143 would be a negative number. That comes out to be negative 81 is greater than equals to 27 n plus 68. Since we can see 27 is a number that's being multiplied by the bracket, right? So we divide both the sides by a 27. It would not make any difference to us. If it's divided by 81 is divided by 27, we are left with negative 3 is greater than equals to n plus 68. We subtract 68 on either sides. And we can say minus 71 is greater than equals to n, or n was less than equals to minus 71. So if we try to draw it on a number line, we can say we mark the starting positions first, minus infinity, positive infinity. We mark this in somewhere in the middle. The greater the number with the negative sign is smaller the number, right? This would be minus 70, minus 69, minus 68, and so on, right? 3 values, 4 values are more than enough. But in this case, it says n is less than equals to minus 71. That means make a circle. Do we see an equal sign? Yes, we do see an equal sign. And the value of n is smaller than minus 71. That means the larger the number in negative, the smaller it is. Okay, do we agree? The arrow goes to the left side of the number line. For the next question, it says solve for u and simplify the inequality such that, question number 13. This is the question number 13 that has been given to us. (172) is greater than u upon negative 12 plus 176. So we know that if it is plus 176, we subtract 176 on either sides. We can say this comes out to be negative 4 is greater than u upon negative 12, right? Can we see the, okay, can I write the same thing as, sorry, can I write this same information as this, sorry, minus 4 is equals to minus 1 upon 12 times u, right? They both are the same thing. That means the coefficient of u is negative. Maybe in the numerator or the denominator, but it is negative. Agreed? So whenever we change the coefficient to positive, right, that means we have to multiply both the sides by a negative 12, right? Into negative 12. And we need to remember that whenever we're changing, multiplying, or we're changing the variable from negative to positive, we have to flip the sign. That means u is greater than 48. So if we have a number line, what can we say? We mark the extremes, negative infinite and positive infinity. U was greater than 48, we write 48. This is positive values, that means this is 49. This would be 50. This would be 47, and this would be 46. We can do as many markings as you want, but a few markings are more than enough. It says U is greater than 48. That means, can U be 48? Because we do not have an equal sign, right? If we do not have the equal sign, that means it's not included. But you can be 49, 50, 60, any number that is greater than 48. Any questions up till now? Do we have any questions? Let's try to do some questions from the test. Okay, just a moment, please. I need to go back to grade 10, chapter 1, lesson number 9, test. Even if we can do 1 or 2 questions from the test, it would be good enough for us. I hope I've covered enough examples so that we would be able to do this. Okay, let me copy the first question. Okay. The question number 1 says, if this is the question given to us and these are the 2 options given to us, we need to find which option is correct, okay, for the test. Okay, I'll give you another way out of this. Rather than solving this question, let's do something else, right? We'll try it multiple ways. If I take b is greater than 33, can I take b equals to 34, right? Can I put the value of b as 34 over here, and I say divided by 12 plus 18 should be greater than 24. What is 34 divided by 12? Oh, that's a fractional value, right? Let's suppose it comes out to be, or rather than 34, can I take 36? That would make my life easier. If we take 36, that means 3 plus 18 is greater than 24. Is 21 greater than 24? No, it is not. But if we take b to be greater than 72, 72 could be, okay, let's suppose if we take any number greater than 72, can I take 84? If I put 84, I took a number that is divisible by 12, right? So this becomes 7 plus 18, that is 25, which is greater than 24. That means this is the answer. Let's confirm. b upon 12 would be greater than 24 minus 18. B upon 12 would be greater than 6. We cross multiply. B would be greater than 6 into 12, and B is greater than 72. So what I did was, if it's an MCQ given to us, we put the values of the options into the value of B and we can still find. Or if you want, you can directly simplify the equation and you can find the answer. Okay? Please do complete the remaining questions, okay? And best of luck. Have a nice day. Take care. Bye.